Good afternoon. Am I audible to you guys?
Yes, ma'am. Yes.
Okay. আজি অলপ সোনকালে ষ্টাৰ্ট কৰিম কাৰণ কাৰেণ্ট নাই।
Yeah, I don't know.
Who is watching video?
Razor mic on আছে।
Oh, কাৰেণ্ট আহি গ'ল। Okay, no problem. Okay, so today we will start new topic which is searching. Anyone can just tell me what is just basic searching? Searching মানে কি হয়?
Ma'am, to find something.
Yes. So like in our normal life, searching is involved like everywhere, right? যিকোনো বস্তুতে searching use কৰো তোমাৰ car keys, then your books, you just keep things here and there and everything. So if you are trying to find anything, some particular thing, that is the searching. To similar thing you can see in case of computers as well, because in your computer there are lots of data are stored. Okay, so to find any particular data, computers use certain algorithms or it has its own techniques for searching any item from the memory. Okay, so there are two types of searching algorithms. Can you see the board?
Yes, ma'am.
Okay. So basically two types. One is your linear searching. Okay, linear searching is also known as your sequential searching. Okay, so linear searching is a very simple one. Okay, it's just normal one, we apply it in array. Okay, suppose you are searching a value or an element in your array. So with the help of linear searching, what you do, you just compare the element to be searched with all the elements present in the array. Okay, so for example, this is your array 20, 30, 12, 3, 50, like this. Okay, so this is your array. Okay, and you are looking for item. For example, you are looking for item 3. Okay, you are searching for number 3 in your array. So what happens in linear search? First, you will start from the first element. Okay, then you will check whether the first element is equal to 3 or not. If not, then you will go to the second element. Okay, then again you will see whether it is 3 or not. If not, again you will go to the next element, then again, and so on. So when finally you will get the item from in your array, then you will just stop searching. Okay, it's very simple one. So linear search, what happens? It's basically used for unsorted array. And it's basically useful for small list of elements. Okay, now this is a small array, right? Suppose you have lots of items stored in your array or in your memory. So if you want to search for something and which is like it's very deep down there, that means what you have to compare each and element every time. Okay, so for this kind of algorithm, linear algorithm, okay, we find the efficiency of any algorithm with two terms. One is time complexity. This is very important concept. You will need this concept in your next semester and next and all. In like everything you will need to know this concept. One is time complexity, other is your space complexity. I won't give you much detail about this because in next semester you will get like a brief details about it. Okay, so time complexity means what? Time required to execute your program. Okay, and space means total memory requirement. Total memory requirement. Okay, so these are the two parameters to find the efficiency of any algorithm. Okay, so for linear search, I'll just talk about the time complexity here. For linear search, time complexity is big O n. Okay, about this notation you will get to know about in data structure in next semester. So okay, so to represent time complexity, we have three parameters. One is best case. I'm just giving you the brief intro. Best case, then worst case, and average case. Okay, so normally we always see the worst case scenario for any algorithm. What is worst case? Means suppose in this ON, big ON. Here n means number of elements. You can just, for the time being, just think n is number of elements. So the time complexity of your linear search will depend on how many items are there in your list. Okay, so it is directly proportional to the number of elements. Okay, that means if you have lots of elements in your array, then it is going to take lots of time, and if it is an array of like small list, then it will take less time. Therefore, linear search is useful for small list of elements only. Okay, programs we will discuss in lab timing. Okay, now just know the concept first. Okay, so what happens here? So as I told you, it will start from the index 1 since it's an array. Index will 0, 1, 2, 3, 4, 5. Okay, so the moment it will find the element you are looking for, it will return the index of that particular item. That means that if you find 3, that means that it will return the index 4. Okay, your searching will just give you the location of that element in your array. Okay, if it cannot find the item in the list, then it will just return -1. Okay, it is possible too, right? Suppose you are searching an item in your array and that item is not in your array. Correct? That means your whole time will be just wasted. So that is another condition for worst case. Worst case means when your item you are looking for is the last item. Suppose you are looking for 50. That means what? You need to, number of comparison you will need is 4. You have to compare each and every item in your array. Then finally you will come to the last one. Correct? Then another condition is that your item is not in the list at all. In that case also you have to compare all these elements and come to the last point. Then you will know that okay, this item is not in my list. So in both cases we measure it the worst case scenario. Okay, best case means when suppose you are looking for the item 20. So 20 is the location 1 itself. So that's the best case. Best case means if the item you are looking for is the first element of the array. In case of linear search, the first item then is the best case. Worst case when the item is at the last position or it is not in that array at all. What is average case? Average case will be like when your item is at the middle portion of the array. So if you are looking for
2
either
and 12.
2, yes, if you are looking for anything 2 or 12, then it will be like average case. Okay, it will take half amount, but average case is kind of negligible. We mainly care about the worst case. Okay, so for best case, the complexity will be O1. Okay, O1 means the first position. Just with one comparison only, not even a comparison, just in one move you will find your item. But in case of worst case, it is ON because it will depend on the number of items in your array. Okay, Vijila? For average case also it will be ON. Why? It's just linear search. So whatever number it is in the middle, anyway you have to compare that much of time. Okay, you can say it should be n by 2, but next semester we'll come to know whenever we have constants like this, we are dividing something or multiplying something, we are going to neglect that term, any constant part. So in average case also it is going to be ON. So but mainly we care about the worst case. Okay, and it is represented as big O notation. Okay, this big O notation is your asymptotic notation. Okay, so there are 3 kinds of asymptotic notation. One is big O, which is used for worst case. One is omega, used for best case, and one is theta notation, which is used for your average case. Okay, so you will learn about this asymptotic notation in next semester in data structure and algorithm part. So for the linear search, that's the basic concept. It will just compare the elements to be searched with all the elements present in the array one at a time. It is going sequentially, therefore another name is sequential. Okay, clear? Linear search. Keep a confusion? Linear search. The concept is clear, right?
Oh, ma'am.
It's like very normal one. The basic way of searching anything. Suppose you have a box of various shapes. If you want to find a particular shape, for example, triangle, and you don't know what are the shapes in that box. So what you will do, you will just take one item at a time from the box, right? Until you get the particular shape you are looking for. So linear search, it's just the basic searching algorithm. Okay, so second type of searching is your binary search. Okay, it is also known as your interval search. Okay, the name is interval search. That means what? In case of binary search, we do not compare the items like for whole array. Okay, we just consider one interval of the array or one part of the array, then we keep searching. So binary search, what happens? It mainly used for sorted elements. Okay, is the very important point. You can apply binary search only in an sorted elements or sorted array. Okay, if I ask you to perform binary search in an unsorted array, then first you have to sort the array, then only you can apply the binary search. Okay. So binary search is a bit different. It is faster than your linear search and it is useful for large amount of data. Okay. When you have large number of array, large number of elements in array, then it is useful. Okay, linear search is for small element array. Okay, if you have less number of elements, then you can perform linear search. If you have lots of data stored, then you can use binary search. So what's the main concept here? It is based on the divide and conquer approach. Divide and conquer. What is divide and conquer? Rather than searching for a particular item in your whole array, it just divide the array into half. Okay, then it search the particular element only the half of the array. So let's just take example again. 20, 30, 10. Okay, sorry, the array has to be sorted. 10, 20, 30, 40, 50, and suppose 60. Okay, the first criteria is that array should be the sorted array. 0, 1, 2, 3, 4, 5. So what binary search do? It will start by comparing the element with the middle of the array or list. That means it directly come to the half part. So in this case, which one is the middle element? There are 5 elements. So if the number is 5, then you can take either this one or this one. Okay, but it's mainly up to you. Either you can take ceiling value or floor values. There is a two term, ceiling and floor. Okay, suppose you have n numbers item, then you will just divide the whole array by 2. So either you can take floor value means whatever here it's 6 elements, 6 divided by 2 is 3, right? So I can just take 3 is the middle element here. Suppose you have 5 elements, then you will divide by 2, then either you can take floor value. Floor value means 5 divided by 2, what's the value? Kiman hoy value? If you divide 5 by 2,
2.5.
2 point something, right?
2.5.
So if you take floor value, then you will consider only the lower bound. If answer is 2.4, you will only consider 2. Okay, that is your floor value. If you have 5 elements, then the middle value will be at index 2. Okay, then what is ceiling? Ceiling will be the next higher value. If your value is 2.4, then ceiling value will take 3. Okay, next higher bound, not the lower one. Okay, for 2.4, floor value will be 2 and the ceiling value will be 3. Okay, this is very important concept. It's used in mathematics as well. But here it's up to you. You can either take the floor value or ceiling value. But basically it's better to use 2. But there's no restriction. Even if you take 3, it's fine. Totally fine. Just that you need to find the middle value first. Okay. Ceiling, floor, clear? Any doubt?
মেম ওপৰখিনি দেখাই দিবচোন অলপ বাইনাৰী চাৰ্জ এইখিনি
কোনটো?
এই ওপৰখিনি মেম স্ক্ৰীনশ্বট মাৰিব লাগিছিল মানে সেইকাৰণে
ওপৰখিনি। Okay. So in this case, total number of elements is 6. 1, 2, 3, 4, 5, 6. I have 6 elements, 6 divided by 2, 3. So at index 3, I'm just going to consider it as my middle element. Okay. Now what I'll do, I'll check what is I'm looking for. Okay. Suppose I want to search 20. Okay. I want to search 20. Now you compare the item you are looking for, whether it is greater than or equal to mid value. Okay, so what is the mid value here? 40. So 20 is less than 40. That means what? Your item should be in this left hand part of your 40, in the lower side. Correct? That means I am going to totally discard this part. Now I will look for 20 in this part only. Okay. So in next page, I'll consider only that part 10, 20 and 30. Correct? 40 pasat egita ase okol 10, 20, 30. I'm not going to search in this part. Why? Because 20 is less than the midpoint 40. And since it is less than and it is in sorted array, obviously the lower values will be at the left hand side of your middle part. So I'm going to consider only the left subpart or the lower subpart only. Okay, so this is your second part. So in this part, again, I'm going to do the same process. That means here also I'm going to find the mid value first. So here mid value is 20. So since searching item is 20 and my mid value is also 20, so your algorithm will just halt there. Okay, suppose here you are looking for 60. Okay, suppose you are searching for 60. Okay, now 60 is greater than 40. So you are not going to consider this part. You will consider only this part of the array because the value you are looking for is greater than the middle value. Therefore, you are not going to consider the lower part of the array. Then, in this case, you will consider only 50 and 60. Here again, you will do the same process. If you are applying a process same process over and over again, then it is also called recursive process. Okay, recursive means you are applying the same step over and over again until you find the item you are looking for. Okay, so in binary search, you just search the item by repeatedly dividing the array into two halves. Clear? বুজি পাইছা সবে? Do you want me to repeat? So in binary case, you will always start by comparing the element to be searched with the element in the middle of the array. Then if you get a match, then you will just return again the index of the middle element. Then if you do not get a match, suppose you are looking for 40 here. Okay, if you are searching for 40 and your middle element is 40, that means you will just give back the 40. So the best case scenario for binary search is when your item you are looking for is the middle element. Correct or not? In linear search, the best case was when your item is the first item. But in case of binary search, your best case will be when the item you are looking for is the middle element. Correct? In the first step itself, you are getting it. Okay, so if the item you are looking for is not the middle element, it will just check whether the value is greater than the middle element or not. If value is greater than the middle element, then we will just pick the elements on the right side of the middle element. Otherwise, we will just take the left side. Then we will start again the same process. Okay. So binary search is mainly useful for large number of array. So if you have lots of numbers stored, then it is better to use binary search because it just completely disregards one half. It's interval searching. That means you can just nullify the half part. You can just compact or optimize your searching. Okay, so just that the necessary condition is that the array should be sorted. If the array is not sorted, then you have to sort it first. Then only you can apply binary search. Okay, so complexity for binary search is O log n. Okay, in most of the divide and conquer approach, the searching complexity is log n. Okay, in next semester you will get to know that for most of the divide and conquer approach, the complexity is log n. Clear?
Yes, ma'am.
Concept বুজি পাইছা for both linear search and binary search? So in linear search, how many comparisons will be there? If number of element is 9, if number of element is 9, then total comparison will be n minus 1. Right? 5টা element আছে, তুমি 4 বাৰ compare কৰিবা, 5th time will get the result. Okay, in worst case. In binary search, you just directly cannot say it's the half because you just divide the array into half part, then you do the searching. So if you take long elements like so suppose this is a bit longer, so middle element will be just this one. Okay, from here 3 elements, from here also 3 elements. Okay, so middle element is 8. If you are looking for any value which is mid, this part is greater than mid and this part is lower than mid. Okay, so if you are looking for 12, then you will select this part. If you are looking for any value which is less than 8, you will select this part, then you will just keep doing the same thing over and over again. বুজি পাইছা linear and search? Binary search is very important in most of the computer things. Computers mainly use binary search because it is faster than your linear search. It is not depend on the number of elements. It's simply cut the half part of the total number of elements. Clear ne sabare?
Ma'am, বুজিছো.
বুজি পাইছা? Okay, good. So in lab class, we will see the program for linear search and binary search. Okay. So next, after searching, the other topic is sorting. Okay. So sorting means what? Arranging items either in ascending order or in descending order. So sorting means basically arrangement of your numbers either in increasing order or decreasing order. Everything has to be sorted. Like in case of binary search, your array should be always in a sorted form. So for sorting, there are lots of algorithms available. Some of the examples are bubble sort, then insertion sort. In second sem, you will just learn about two sorting: bubble sort, insertion sort, and selection sort. Okay. Other than that, you have heap sort, merge sort. There are lots of sorting algorithms available in your literature. Let me see the syllabus ones. Yeah, 3 sorting algorithms are okay for you guys: bubble, insertion, and selection. But yeah, they mention about the quick sort and merge sort in the function program. So let's see the bubble sort. Okay. I'm going a bit fast because maybe your exam will be in July itself. So we might not get enough time to finish your course. So I just want to finish the course as soon as possible. Okay. So if you have any confusion or anything, you can just directly ask. Okay. So I hope this part is at least clear to everyone. In searching part, searching is not that complicated, just that one is linear search and one is binary search. Concept is very simple. Okay, so just remember, binary search uses divide and conquer. Divide the array into half, then keep doing the things. Okay, so let's come to the bubble sort. Bubble sort is the most simplest one. Okay, the very basic algorithm, sorting algorithm, is your bubble sort. So it just repeatedly compare adjacent elements and swap the elements. Okay. So for example, okay, let me tell you the steps. So see, suppose you have items like 2, 10, 20, weeks, 50, like this. So this is basically all unsorted. This array is not sorted, right? Or it is like list with unsorted array. So what you can do here is you will start with the first element. Okay, you will start with the first element, then you will compare it with the adjacent element. Okay, so then you will see whether this element is greater than the adjacent element or not. If not, then you will not swap it. Okay, if the item, if this first element is greater than second, then you will just swap the value. But here 2 is already small, so I'm not going to swap it. Next you will do, you will compare 10 and 8. Okay, between 10 and 8, 8 is the smaller, right? So you are going to swap the value of 8 and 10. So it will become 10, 20, 6 and 50. Okay. So next we'll compare 10 and 20. This one is already sorted, so no need to do anything. Then you will compare 20 and 6. Now 6 is less than 20, so you will swap the values again. So now it will look like 10, 6, 20 and 50. Okay, next you will again compare 20 and 50. Now these are already sorted. So this first pass is done. Okay. Next, you will again do the same thing. Okay. This is pass 1. Okay. In second pass, you will again do the same thing. You will compare 50. Compare 2 and 8 already sorted, no need to do anything. Then compare 8 and 10, no need to do anything, sorted. Next, 10 and 6. 6 is smaller than 10, so you will swap the values 6 and 10. 20, 50. Okay, next pass again you compare 10 and 20, already sorted. Next you compare 20 and 50, already sorted. Don't need to do anything. So pass 2, done. Okay, next you will start again comparing. Again you will start from 2, 8, 6, 10, 20, 50. So again compare same 2 and 8 already sorted, no need to do anything. Next you compare 8 and 6, 6 is smaller, so swap the value 8, 10, 20 and 50. Next you compare 8, 10, no need to do anything, then 10, 20, no need to do anything, then 20, 50, no need to do anything. So this is your sorted array. So you can compare the thing just one at a time. You just simply cannot compare one value with all the elements in your list. Okay.
Yes, ma'am.
বুজি পাইছা bubble sort?
Yes, ma'am.
Okay. So in this case also, since if there are n number of items, the total comparison will be n minus 1 times. So for n minus 1 times, the process will be repeated. Okay. I can show you another example with like array. Suppose this is an array. 5, 1, 6, 2, 4, and 3. Okay, so first you will compare 5 and 1. So 5 is smaller, right? So you will interchange the values. So your array will become 1, 5, 6, 2, 4, and 3. Right? Next, you will compare 6 and 2. Okay. Now 2 is again smaller. So your array will become 1, 5, 2, 6, 4, and 3. Okay. Next again, you will compare 6 and 2. Again, 4 is smaller. Your array will become 1, 5, 2, 4, 6, and 3. Okay. Now, again, you compare 6 and 3. Again, you need to sort it. So 1, 5, 2, 4, 3, and 6. Okay, so ultimately you came to the last point. Okay, no more things to compare. Correct? You have compared last year, no more things to do. So again, your same process will start from here. Okay, that means this is your first pass. This is pass 1. Then in the next part, you will again start from the beginning. You will start with this one. 1, 5, 2, 4, 3, and 6. Now you again will compare this one, then interchange, and so on. Okay. বুজি পাইছা?
Yes, ma'am.
So today we have checked 3 things: linear search, binary search, and bubble sort. Bubble sort is the most simplest one out of all sorting, and linear search is the simplest one out of 2 searching. Okay, let me take attendance before it's get card. Switch on your videos. কৌশিক বুজি পাইছা? অমনদীপ, দিলবৰ, শ্ৰেয়া, দাদিবতে, বান্তে, বিশালমণি, জিনচু আনমং, 26 টা সদায় এইকেইটাই কেইটামান কেতিয়াও নাই বিষ্ণুপ্ৰিয়া কোন হয় কেতিয়াও ক্লাছ কৰা নাই কোনবাই চিনি পোৱা নে হু ইজ বিষ্ণুপ্ৰিয়া
মেম চিনি পাওঁ
মাহীয়ে মাহী
এই নহয় sorry মোৰ আইতাই কিবা কিবি কৈ আছিলে okay attendance done tomorrow is a holiday so enjoy your holiday long holiday Friday Saturday Sunday বন্ধ
মেম আমাৰ জাপানিজ ওয়ার্কশপত কি কৰাব
কি কৰাব
মানে জাপানিজ ওয়ার্কশপ আছে
এইটো নাজানো নহয় ওয়ার্কশপটো কৰি চাবা গম পাবা আৰু বাকি গিটা হ্যাপি
এটো কি সাবজেক্টৰ এক্সাম হ'ব নেকি
না 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 সেইবোৰ এক্সট্ৰা হয় that's up to you
কম্পালসৰি তো নহয় ন এইবিলাক কিবা
না এইবোৰ কোর্স রিলেটেড নহয় কোনবা যদি ইন্টারেস্টেড হয় জাপানিজ ল্যাঙ্গুয়েজ শিকাৰ তেতিয়া ওয়ার্কশপটো কৰিব পাৰা মানে এইটো তোমাৰ ওপৰত ডিপেন্ড কৰে কৰিব খুজিছা নাই কৰ মানে একো মানে ইম্পোস্ট কোর্স নহয় ওকে
মেম এক্সামটো নহয় ন এইটোৰ
নাই নাই এক্সাম ওয়ার্কশপ হলে সিহঁতে নিজৰ ফালৰ পৰা কিবা এক্সাম বা এনে কুইজ টুইজ থাকিব পাৰে বাট কলেজৰ এক্সাম নহয় মাৰ্কছ নাথাকে সেইবোৰ প্ৰাঞ্জল দাস অৰ্ণৱ জ্যোতি ডেকা আথৈ চানা দাদি আনিশা শ্ৰেয়া দিলৱাৰ অমনদীপ